Bert, today I would like to discuss the following statement with you. Is data which is good enough for operations also good enough for analytics or not?
Very interesting concept. Let's maybe start with why is data good enough for operations?
Yeah.
If we talk OT, IoT data and link it to manufacturing operations, you'll see that there are a couple of things there. There's like control system. Every control system has typically a panel operator. We all dream of the autonomous plants, but not a lot of examples we can already name. But also, next to the control system, you have an alarm system, a very popular topic, where we can rely on alarms to get alerted when something would go wrong. And on top of that, we also have safety systems. And indeed, there's always that human in the loop, somebody safeguarding to see if things are running normal or smooth. That means if we see bad quality data from the field, which can come from a sensor that is not doing or sending the right values, or that suddenly has a misconfiguration with respect of like a unit after a maintenance event, or the sensor is by aging a little bit deteriorating and like fouling, drifting away, sensors with calibration problems, or also like a lot of sensors in the field start to what we call flatlining. The more technical concept is what we call stale data. The question is that data flows through the control system, and if it's not stopping the process, there's somebody watching if everything is like behaving normal, it's not always a problem. And then you also have the fact like, even if data is like percentages off, if it's not causing that problem by operational downtime, what is the big problem? Yeah. But the big problem comes that data is also then stored in a warehouse like a data historian, and there the problem is introduced because once it's in that historian, it's there forever, or as long as you keep the data. And that means if it's then wrong, not presenting the physical state of the process or the sensor was wrong, for everything that will happen downstream, what you ever want to do with the data, in data products like reporting, emissions reports, AI models, or you want to base on for predictive maintenance, your digital twins, it will stick and you will have to deal with it after the effects. And there the problem is introduced, but that means it's not always the problem in real time of the operation, you understand? And that is something where I see an awareness coming in the industry that indeed we are now solving data quality problems post or after the effects, reactive. That is now step by step shifting to a proactive way, because understanding if we deal with it after the problem is generated, it will cost much more time and headache to solve it in comparison if you would tackle it proactive. Yeah. And that is a shift, a mind shift.
So garbage in, garbage out.
Exactly.
Yeah. And that means that if you talk about operations, we focus typically on operators on their SCADA DCS system responsible for the day-to-day operations. When you talk about data products, then you probably mean, I would say, the rest of the company, where can you give maybe a couple of examples?
Yeah, that's outside of the level 3 or the MES stack. That's indeed when you talk about the business. The business requires a report for all my plans. I want to track energy consumption, for example. I want to centralize the emissions for a corporate dashboard. Use case like OEE, all the things that you can look at the plant level, but also on a corporate level. But also much further, like for example, AI model for predictive maintenance, also data product. You are, for example, subscribe on that. You want to see if what's happening, but it goes even beyond that. Like you see a lot of data being shared today with clients, but also with suppliers to improve like your service level agreements. Well, if data is shared and used by a third party, they are never aware of the problems you had in your operations. That means you're responsible for, if you deliver them data, that the data is reliable. Yeah. So data reliability, one version of the truth, not everybody that's doing some cleansing on its own, that's becoming a corporate kind of responsibility. And the thing is there, a lot of companies say data is an asset. If data is an asset and not a liability, they have to treat it in that way. And quality of data is part of it.
And how can Timeseer support that mission?
Very simple. We scan and we score data for quality, like thumbs up, thumbs down. How good is it? Where are the problems? You can do the root cause analysis. Why are the problems there? Is it a problem with your data acquisition system? Is it more on the sensor level? That's the first step. We do that quality scanning over time, which is the monitoring, but we also do the generative cleansing part, where we help clients to go from a raw, unreliable version to a clean version, and then indeed using that cleaned, fit for purpose, trusted part of data to be used for data products.
Okay, Bert, you know I'm a big fan of artificial intelligence, AI. I would like to discuss the following statement with you. AI needs data quality, but data quality also needs AI. Is it right or
Completely agreeing with you here. Yeah.
Okay.
I think it's also aligned with the mission of this company, of Timeseer, where we indeed started by being inspired by people like Andrew Ng from Landing AI, saying like, hey, we don't need better models, we need better data, we need to move from like a model centricity to data centricity. That's like the why behind this company. So that means I think everybody's now like aware that if you want to do AI and scalable AI, it needs like a certain quality data, garbage in, garbage out. And we see indeed a lot of times being wasted on cleansing the data after the effects. But also, if you want to tackle data quality at scale and go from an unreliable version to a manageable state, you also need AI. And that's an interesting thing. And the AI is introduced at a couple of levels here. It's on one end, there's the algorithms you need to detect quality problems, especially in an OT, an IoT mindset. You're talking sensors. That means you need to tell when a sensor is behaving abnormal, for example, or it's doing things that you don't expect, corresponding to the state of the process or the asset or the device. And to make that manageable, a lot of the times you need AI, because if you would not use more sophisticated models or like checks, what we call, you would get a rain shower of alerts. So for example, if you would just flag an outlier, and that outlier happens a lot, you would get that rain shower. So to go into like a precise, accurate version of, do we have a data quality problem, you need to know the background, you need to see what I'm looking at. And so AI is very important on the detection side already. But you also need AI because, again, if you're monitoring quality of an entire system, all historians, the tendency indeed to go from big data to small data is important for result interpretation. You want the top 2-3 problems of the day, and we see like if you're just doing it with scripts and basic checks, it's very difficult to go into that manageable state. So you need AI to do, for example, some co-pilots to help you in reduce the amount of alerts and help you to go to the right alerts, the most important one of the one that can go together, like grouping of problems or linked together. And there's a third part where also AI is necessary, is for the cleansing, like the generative part. If your data is bad, you need to store it, repair it, clean it. AI can help you to go into like a good shape of data where it's cleansed and augmented, corresponding to the use case, and not just once, but also when new data comes in, you need to do the cleansing like in a pipeline fashion. So
that's super interesting. So I remember AI needs good data, but good data also needs AI to make that manageable. Suppose somebody who is watching this video wants to take steps, wants to apply these clever algorithms to check whether data quality is an issue. How should they start?
Well, you can start from two angles. Like you can have data scientists already working with the data. We invite them, like use Timeseer, see what checks we are giving out of the box. It will help your journey. We can reduce the data science journey with 50% at least on the cleansing. That's like inviting the data science community on trying Timeseer. On the other hand, the business, they want to build a business case. Why should I act? And why now? And there is like, okay, that first step is do an assessment of your data. We can connect on your systems and see, like a virus scanner would do a couple of years ago, where are the vulnerabilities? What are the data defects? Where is the data downtime? What is causing it? And where is the effect in your data pipeline? What is the effect in your data products? Building that business case based on like the assessment, that's what the business should do.
Okay, perfect. Thank you very much. Very interesting. And to our viewers, if you want to check for your data defects, feel free to reach out.